All right, ladies and gentlemen, so the idea is that we are on lesson 8.2, applying exponent properties involving quotients. Okay, x to the, I don't know, let's say 4th over x to the 3rd. And as we stated, writing it in expanded form is how many x's do we have multiplying up top? 4. So 1, 2, 3, 4. Okay, and then down below, how many will we have? 3. 1, 2, 3. Now, this is the expanded form, and what we could do is we could start canceling them out. So therefore, because they're all multiplying, the opposite of multiplication is division, actually, is division. And so we are dividing, hence we have this division line. So these guys would divide out, cancel out, cancel out. And so all we have left is a single x. Okay? And when I say cancel out, it cancels out to 1. All right? So we're really left with x over 1, where that's equal to x. And the way that we previously showed this is that I can show it as subtraction. X to the 4th, we see here, minus x to the 3rd. So 4 minus 3 is going to give me x to the 1st. We see that both of these answers are the same. Is that all right? OK, cool. All right, let's continue. And let's do it with actual integers. So let's say if we had the example that they give us in the book is 8 to the 10th over 8 to the 4th. I'll just change it up and say 8 to the 6th. All right, so we'll do it this way. Now, I could do it in expanded form and give you 10/8 up top and 10/8 and 6/8 on the bottom. We'll start canceling them out. Do I need to do it that way? No. So what's another way I could do it?
Subtract 6 from 10.
All right, so we can go ahead and write the same base. This guy is called my base. Is everybody all right with that? And so for the exponent, I do the numerator exponent first, and then I'm subtracting the denominator exponent. Everybody's OK with this? All right, and so as was stated, I am subtracting 6 from 10, and so I'm left with 8 to the 4th power. OK? Is everybody all right with that? All right. Cool. Let's do another example. Now, sometimes we'll have more than just one thing. Let's say if we kind of combine these. Let's say if I had 8 to the 5th, x to the 3rd, y to the 4th, over 8 squared, y squared. OK? All right. So we can only do the subtracting exponents things if the bases match. OK? So do we see matching bases here? OK? And so what matching bases do you see?
8 and y.
OK, so 8 and y. So I can go 8 to the 5th. Give me some more. Minus 2. OK, and I'm just going to leave x to the 3rd. And then I get y. 4th minus 2. Is this OK? Are we good on that? OK. And so let's do it. What do I get here?
3.
All right, so I get 8 to the 3rd. Anything happen to this one?
No.
So it stays the same, x cubed. And the final one? Y squared. Good here? All right, and if I was going to finish this out all the way, I'd go ahead and get 8 to the 3rd, which means I'm doing 8 times 8 times 8, which is basically 64 times 8. Don't remember it off the top of my head. All right, awesome. So let's go to the next part. Let's say we have fractions. Let's say we have 3/4. All right, and I'm doing exponents. We've kind of talked about this once long ago. And so what this would imply is that, like before, this exponent distributes down into these two, which would give me 3 to the second power over 4 to the second power as well. OK? Is everybody OK with this? All right. And if I was going to go ahead and express it out all the way, I'd be left with 9 over 16. Yes? There's no surprise on that? Everybody's OK? All right. Now, when it comes to something along the lines of looking at, let's say, a negative of 3/4, and I was going to go ahead and say this is squared, you actually have to choose the negative to go with one of these, either the numerator or the denominator. It really doesn't matter. OK? It really won't matter too much. All right? So, for example, I could either write this as negative 3 squared over 4 squared. Is everybody OK with that? Or I could have written it as 3 squared over, give it to me, negative 4 in parentheses squared. Is this okay? You're all right with this? Okay. That's the way I would like you to do this. Comfortable with that? Okay. Let's take it. Let's take it one step beyond to make it just a little more complex. This is an example 3. If I'm looking at something that looks like this, 3a to the 4th. It's not in your book, but it's up here on the board. 5b, and we're putting it to the 3rd power. All right, flip that out. So how does that this cube up here? What does that do? Help me out.
Distributes.
Yeah, it distributes into everything in there. Is everybody okay with that? All right, so how many things is it hitting up top here in the numerator?
2.
It's 2, like blow, blow. All right, so I get 3 to the what up top?
3rd.
3 to the 3rd, and we get a to the 12th. Down below, what's happening? So I get 5 to the 3rd, yes, and b to the 3rd. Okay. How are we doing? Doing okay? All right. Now, if the problem had said to me, simplify, there's 2 ways it can ask me to do it. If they say simplify using expressions, using exponents, then I'm done right here. Okay? Because I've simplified using the exponents. But if they just say simplify, that means I actually have to multiply this out. Okay? And so if that's the case, then I say, hey, what is 3 cubed? Well, it means 3. We can say it louder. It's okay. 3 times 3 times 3, right? So what is 3 times 3 times 3? So I've got 27, a to the 12th. And then let's do this one. So I've got 5 times 5 times 5. So what's 5 times 5? 25. What's 25 times 5? $1.25. All right? And this would be my answer. Okay? All right. So if it says simplify the expression, this is what this means. So for your homework tonight, you are going to have to multiply some of these out. Thankfully, it's not like 42 to the 13th power, like on that previous homework assignment, right? That kind of stuff definitely use calculators for. That's ridiculous. But for tonight's homework, where it gives you like 4 to the 3rd, you can do it. I believe in you. All right? So one final one. Okay. Let's write this one down as well. If we have x cubed, y, we're going to put this to the 7th power times 1 over 3x to the 8th. All right. Talk to each other real quick about what do you do first. What do you do first? What should I do first?
Distribute the 7.
Right, let's distribute that 7. So I end up with x to the 21st, thank you, over y to the
7.
Beautiful. And then it's multiplying times 1 over 3x to the 8th. What can I do with this? What can I now do with this? Thoughts? Yeah?
Cross cancel.
I can cross cancel, sure. Yeah. So if I cross cancel, what am I cross canceling out? X's, right? Yeah? I could also go ahead and I could combine these. All right? I could combine. And I could go ahead and say x to the 21st times 1 gives me x to the 21st. No surprise there? Is everybody okay with that? And then over here, if I multiplied this guy and this guy, then I'd end up with 3x to the 8th, y to the 7th. Is there any surprise there? Okay. So now I could have either cross-canceled him and him, or I can just stack them and then I can do the subtraction thing. Yes? All right, so I'm looking at x to the what? 21st minus, that was 21st minus 8. That's right. So what is that going to give me? Yeah, 13. So I have x to the 13th. Now what happens to the rest of these bad boys down here? I've just taken care of the x's. What happens to him and him?
They stay the same.
They stay the same where?
As the denominator.
Yes, as the denominator. Very nice. Y to the 7. How is that? Is that okay? All right. Any further do you have questions about this? No. Okay. You may. Great. So that is where I'm going to stop.